So once again, welcome everyone. So thank you for joining us today. Ippadiki, we'll be starting off with uh, just an overview of what we are going to cover this meeting. So yeah, number market panade வந்து it's like Redstone circuits, right? Redstone Electronics. So you know that Redstone is a part of the Minecraft, and you'll be implementing some electronics concepts in Minecraft. That is the most accessible EDA tool. EDA meaning electronically. EDA varthu vache.
Design automation tool.
Yeah. So electronically design automation tool, which is more accessible compared to like tools like Cadence, would be Minecraft. I know it's a very great exaggeration, but yeah. Okay, what do we mean by the electronic concepts? So, since we have some first years along with us, we'll start off with the basic concept of semiconductor. So we know that we have learned about conductors and we have learned about insulators, right? Semiconductors another. அங்கிக்கும் ஒரு கால் இங்கிக்கும் ஒரு கால் நடுவுல இருக்கு. So you can basically modify the way a semiconductor behaves. It can be used as a conductor or as an insulator. So how do we get semiconductors? So basically when we talk about semiconductor materials, often come across the element silicon. So we use the silicon, which has 4 valence electrons, and which like you could use that to manipulate it by making it either as a good conductor, comparatively good conductor, or a comparatively good insulator. Okay, so this is the semiconductor concept. Next to this, how do you make it a bit conductor or insulator or as an insulator? So this is where the concept of doping comes in. So doping na enna pandrom, we add on impurities to it. What do we mean by impurities? Impurities is basically the electrons which we introduce. When it comes to impurities, as far as semiconductors or silicon is concerned, as far as doping concept is concerned, we only worry about the electrons. We know that more the number of electrons, more is the capacity for the particular element or the particular material to carry the current, right? So based on that, if we introduce more electrons, as electron count increases, the current increases, which implies it becomes more conductive, and vice versa, right? In the concept of that is where.
And இது வந்து தூங்கிடாதீங்க, இன்னும் கொஞ்சத்துல மைன்கிராஃப்ட் ஸ்டார்ட் ஆயிடும். நீங்க நிறைய பேர் மைன்கிராஃப்ட் அதெல்லாம் வந்துருப்பீங்க தெரியும். We'll get that. இது எல்லாமே கொஞ்சம் we'll join it together.
So yeah, right. எங்க விட்டேன் electrons. Yeah. So இது வந்து more of the physics concept. Okay. Now, based on this doping concept, we can like the more electrons you add, that particular material will be considered as n-type material, n-type silicon here in this case. And if the like the absence of electron is more, meaning the hole concentration is more. Like hole is nothing but absence of electrons. And the concept வந்து நிறைய பேருக்கு அது இன்னும் பழகி இருக்காது. So it's not like a separate entity. It simply emphasizes on the fact that there is no electron present at that particular area. So as the absence of electrons increases, we get an p-type silicon. Okay, so based on this too, we come up with a semiconductor device. Now here is where the device concept comes in. The most simplest and the most rudimentary device would be the PN junction diode. So here we have this p-type silicon here and the n-type silicon here. Okay, either one we don't attach two different materials together. It is just one material, and we introduce the impurities here. It's just one block of silicon. Here we add electrons, and here we remove the electrons, or I could say I'm using the bitwise operator. Okay, so just to signify that this area is devoid of electrons to some extent, and this area has more electrons compared to the normal silicon configuration. This gives us this PN. As far as PN junction is concerned, any kind of a concept which you take, like thermodynamics or liquid mechanics, whatever it is, we have something called as equilibrium. Same concept comes over here. So initially we had this P and then. Now you might think, எதுக்கு இந்த line? Why are we adding these two lines? Okay, So basically, same as like for a very hot object, when you keep it in a normal environment, you see that there are some water droplets in that particular container, outside the particular container, because that's the clash of the environmental temperature and the hot body's temperature, because of which you see those water droplets condensing, which tries to ensure that there's an equilibrium. Both are in the same temperature. Adhe concept. Here, these two elements, this P and this N, try to neutralize each other, as in redistribute their electron density. So the analogy would be the temperature thermal equilibrium. அந்த கான்செப்ட்ல தான் வந்து இங்க you have more electrons and you have absence of electrons here, right? So these electrons try to come and neutralize this. அதுக்கு முன்னாடியே இங்க தான் நமக்கு மெயினா அந்த டிவிஷனுக்கு லைக் we have seen here the PN junction இங்க இருக்கிறது தான் PR interface. So the ones which are here nearer to here, this area, will get neutralized first. Now, does it mean that entire இப்போ நான் இங்க கொடுத்திருக்கேன் 100 degrees Celsius and 0 degrees Celsius? So it does not entirely switch as this side as 100 and this side is 0 degrees. It sees a mid state between those two. That is why the entire thing does not neutralize itself. We have this area alone getting neutralized. In the area மட்டும் உங்களுக்கு neutralize ஆயிடும், where you have just the silicon over here, which has no impurities, no electrons, no excess electrons, and no absence of electrons. It is just that material alone is there. So அந்த ஒரு கான்செப்ட் தான் வந்து we call it as depletion region. So this is what we call as depletion region. So far so good. இது வந்து மைன்கிராஃப்ட்ல நீங்க டைரக்டா பார்க்க மாட்டீங்க, but this is the basics, since we also have to mention about how this is coming, in what way is this electronic concept அந்த மாதிரி. So here Stephen reactor மத்தவங்க தூங்கிட்டாங்க தெரியலையே, மத்தவங்க என்ன ப்ரோ நீ தெரிஞ்சதே சொல்ற அப்படின்னா
என்னடா நம்ம டீச்சர்ஸ் மாதிரி சொல்றோம், ரியாக்ட் பண்ணுங்க என்ன தூங்கிட்டீங்க சொல்லிட்டு அட்டெண்டன்ஸ் எடுக்கிறோம் நம்ம. கைஸ் மைன்கிராஃப்ட் வரோம், we just need ஒரு டிரான்சிஸ்டர் இருக்கும், we have to explain just ஒரு பேசிக்கா. எனி டவுட்ஸ்னா கேளுங்க, பிரச்சனை
ஒரு 4 minutesல கன்வர்ஜ். சரி ப்ரோ அட்டெண்ட் பண்ணி
சரி ப்ரோ புரிஞ்சிச்சு.
ஓகே, சோ இதே கான்செப்ட் தான் இப்போ நம்ம டிரான்சிஸ்டர்ஸ் பேசுவோம். எஸ்பெஷலி டிரான்சிஸ்டர்ஸ், we say it dominates or it rules the technological world. இப்போ in what way is this PN junction related to transistors?
Hey, before that, why do we even need transistors, Aditya? I have a question. Why do we need it? Yeah, why?
What is a transistor? Why do we need it? Yeah, so exactly transistors now, it is adoda you could say it's an expansion is transfer of resistance. Okay, transitional resistance, you could say it like that. So இப்போ நம்ம படிச்சோம் இல்லையா இந்த மாதிரி we have switches, basically a mechanical switch, the switches which we have in our rooms. You have to give a manual input to establish a electrical output. அதாவது அந்த ஒரு வயர் அந்த சர்க்யூட்டை கம்ப்ளீட் பண்றது வந்து உங்களோட மெக்கானிக்கல் இன்புட் மேலதான். வாட் இஃப் த இன்புட் இஸ் ஆல்சோ எலக்ட்ரிக்கல்? அதுதான் வந்து ஒரு டிரான்சிஸ்டர்ஸ் பண்ணும். Transistor is again a device like our PN junction diodes, whose applications is seen in two ways, either as an amplifier or as a switch. இப்போ amplifier எந்த மாதிரி கேஸ்ல வரும்னா, when you have mics, okay, you have a microphone, you sing to it, and உனக்கு ஸ்பீக்கர்ல வரும்போது நல்லா லவுடா கேட்குது, கரெக்டா? So basically you have a amplifier in it. It amplifies the signals, like your voice signals will be sent in as input. That will be translated from analog to a digital domain. In I have abstract சொல்றேன், which we will cover it later on in the upcoming sessions. Digital domain க்கு மாத்தின அப்புறமா it will go through these kind of transistors or these kind of devices, gets amplified, and it comes to the output, which reaches to our ears. This is one application of transistors. Now, switches. When it comes to switches, deep information, please. When it comes to switches, we majorly know about these two things, which is FETs and BJTs. These are two different devices. FET meaning field effect transistor. இப்போதைக்கு first years இருக்கிறவங்களுக்கு this might be too intensive. I'll just give you the abstract of like crux of the information at the end. And BJT is bipolar junction transistor. So இது ரெண்டுமே வந்து we'll be facing when we come to transistors, when we deal with transistors. For now, let us not consider BJT for the time being. Let us just focus on FET. இப்போ நான் PN ஜங்ஷனுக்கு காமிச்ச மாதிரி you have a structure like this, right? இந்த ஒரு ஸ்ட்ரக்சர் மட்டும் நீங்க சும்மா ஞாபகம் வச்சுக்கோங்க. We still haven't gone into the working of it. I'll just give you another structure of FET. When we talk about FET, there are different types of FETs. Field effect transistor, you have junction field effect transistors, and have thin film field effect transistors, and you have metal oxide semiconductor field effect transistors. Predominantly, we talk about MOSFETs, which is metal oxide field effect transistor. Okay, so these three words are our main key points. This explains the device structure itself. Apdi pata, I could say, yeah, we'll consider the most rudimentary shape would be a rectangle. Now, in the rectangle, I'm introducing two more rectangles. Okay, here one and here one more. Let us assume these both are of the same size. Okay, super unlike beneath. Sorry, bro. Come, ayo. Sorry, guys. Yeah. So this would be okay. ஏதோ ஒரு பர்த்டே கேக் மாதிரி வரைஞ்சிருப்பேன். So this is field effect transistors. Okay, MOSFET. Now, MOSFET வந்து you'll again, thank you bro, thanks. MOSFET வந்து again you'll be having two types. MOSFETs வந்து you have N type, which we call it as NMOS. Okay, and P type MOSFET, which we call it as PMOS. Now, what does this N type and P type signify? இங்க வந்து உங்களுக்கு இப்போதைக்கு let us just consider NMOS. NMOS meaning இப்போ இங்க இந்த ரெண்டு குட்டி ரெக்டாங்கிள் இருக்கு இல்லையா, here you will be having N type semiconductor. So the silicon atom, the silicon material with more number of electrons present, highly, and the N plus stands for highly doped. So you have these two over here, and இங்க பெரிய cake, பெரிய cake வந்துச்சு. So this should be the P substrate. இந்த ஒரு particular portion of the device is called the body or substrate
or cake.
Yeah. And இங்க நம்ம பார்த்தது வந்து it can be interchanged also. So let me consider this as source and this as drain. Okay, so far so good. We have one body, we have one source, and we have one drain. இப்போ இங்க இருக்கிற வேற கலர்ல இருக்கிற இந்த டாப்பிங்ஸ் என்னது அப்படி பார்த்தா நம்ம இங்க நான் சொன்னேன் இல்லையா, மெட்டல் ஆக்சைடு செமிகண்டக்டர். So here you'll be having a metal, here you'll be having oxide, and this portion in the P is nothing but it's a P type semiconductor, right? So this is again semiconductor.
Okay, hence, one random question.
Yeah.
So,
hello.
What is a capacitor? Anyone can just unmute and say capacitor na enna?
Used to store charges.
Okay, how is it constructed? What are the let's say 3 different layers? What are the 3 different layers that you need, or 2 technically?
What makes a transistor a transistor?
Not transistor, capacitor.
Oh, sorry. Wait. Okay.
2 conducting plates and a
Exactly. So what do we have here? We have a metal on top, and we have a semiconductor on the bottom. Okay. Yeah, and the oxide in this case would act as a dielectric. So what do we essentially have here?
A capacitor.
There we go. Okay. So I just wanted to make that point, and Aji, you go ahead.
So this is the reason why we use transistors in the technological field, because any kind of element which you have studied till now, till class 12 itself, would have studied about resistors, capacitors, inductors, and everything. All these behaviors can be simulated using this one putty device. This transistor alone is enough to simulate or emulate the behavior of the other electronic components which you have studied till now. Yeah, so I think for now we can switch to Minecraft. I'll explain more about this later on. And I கொஞ்சம் bore அடிக்குது. Yeah, as for like till now it's okay, right? So you have the source, you have the drain, you have the body, and this thing over here, the metal, the things over here. Yeah, okay. I'll just use another color maybe. Yeah, we have these lines which we call as terminals. So this is how we connect or give some kind of potential to the device. Okay. So this is how we basically access these different portions of the device. Okay, bro. I think we'll continue with this later on. We can do it more.
Sure.
Okay. So, up I'll have to explain about P-type also. Okay, P-type is basically the same thing. Can I copy this? Let me just see. Want this? Okay, duplicate. Okay, that's. I think we managed this. Just a minute. Let me just erase these things. Why? Yeah. Okay. So right now we had already seen the N-type MOSFET, the N-type device version of this. Now, what do I mean by P-type MOSFET or PMOS? Nothing. All you have to do is just interchange the materials used here. The two small portions was N plus, but in the case of PMOS it becomes P plus. Okay. Here you have another P plus, and here you have an N body substrate. The connections remain the same. So here, okay, let me keep this as source. Let me keep this as gate. This would be the drain, and this would be the body or substrate. Okay. Now, we have two different applications. One, we could use it as an amplifier, or we could use it as a switch. Right now, we'll focus on using this device as a switch. Switch in the sense, basically, we get that manual input for which you have an electrical output. In this case, that input will be provided at the gate. Okay. So now comes the concept of channel. What do I mean by channel? Ipo, you have the source portion. I think I have this another pen over here. Just a minute. Okay, I am struggling. You know what? We'll just leave it out for now. Okay. So we have this P-type source and this P-type drain. Both are of the same material. Okay. Now, when we have some other material of the same type connecting these two source and drain, it basically implies that we have bridged these two portions and now they are of the same potential. When it comes to potential, that's kind of a tricky concept. So, say you have a potential here as 5 volts. Okay. Here also you have some unknown potential. Okay. As long as there's no connection between those two, X cannot be determined. So even if there's a small connection over here, it implies that X is 5 volts. Got it? Cool. So same kind of thing. Now I'm just going to draw the source and drain. Let me again consider a NMOS case. What is NMOS? So here you'd be having N plus, here you'd be having N plus, here you'd be having P. Okay? This is just an abstract version. I don't want to go more into it. So here again you have the P substrate in this area. Now, since you have a the metal and the oxide over here, now you could establish a channel or a bridge which could connect these two areas just by applying a potential over here. How is that possible? Meaning, இப்போ வினித் ஏற்கனவே சொல்லியிருந்தான் இந்த மாதிரி you could use this as a capacitor. How do we realize a capacitor through this? Meaning, this would be the metal, this would be the dielectric, and this would be the metal again. Okay, so let me just do this. Yeah, இப்போ நீங்க PN junction diode படிச்சிருந்தீங்கன்னா you would know that there's this concept where you could literally make your depletion region disappear by applying a certain amount of potential difference. Like inga pathina, here if the potential difference is say you have to apply a minimum of 0.7 volts. The potential difference over here to here is 0.7 volts. This depletion region ceases to exist and you have a perfect wire kind of a condition. So it, you could say it basically does not provide any resistance. As long as you don't give this particular potential difference, you won't have any current flow. That is why in diodes you usually see this kind of a graph. This would be 0.7 volts. Okay, so this is I. We'll be going into the physics concept later on. Since this is more related to Minecraft, I don't want to go into this much. So yeah, the concept here you'd be having in MOSfet, but in this case we'll be using our capacitor knowledge. So once you apply a particular voltage over here, say I'm applying 0.3 volts, inga vandu the though it is a p-type substrate, there will be some level of electrons in it. Okay, it's not completely devoid of electrons, it has some level of electrons. Due to this capacitive effect, the one which you apply here as positive, you could again see this here coming up as 0.3 volts. It is like a positive, negative kind of a cascading effect, which ultimately brings the fact that this kind of a case. Let me just shut this off. So yeah, you'd be forming a channel here. Channel is nothing but the electrons which are over here. There'll be small kuti electrons. They all move over here because of the potential, positive potential applied at the gate. So therefore, this these electrons, they just go here and they bridge the gap between the source and the drain. Therefore, you have a channel formed here, meaning this is basically a concept where you have these two tanks. Okay, you have water here, okay, and you have water here. If this wall is there, this wall over here, if it is present, you will not be having any movement of water between these two tanks. Suppose if I break this wall and I make it somewhat like this, okay, you will have water flowing on down here. This height could also be changed by the potential which you apply at the gate. So now if I make this 0.7, okay, 0.7 volts, then the analogy would be like this. You'll have a much more easier, you'll give a much more easier way for the water to flow from one tank to another. That is the same which happens here, but in this case, instead of water, it is the electrons. So yeah, this is what we call as channel formation. I think I just went through a lot of stuff over here. So let me just recap. Just a short recap. Tell me, what else do I need to cover, bro? Just tell me that.
Just basic வந்து இப்போ NMOS, if they're all clear with NMOS, just say how the inputs to P and NMOS differ and what the outputs you get. First, let's see. Anyone have any doubts up to now? Do you need any specific topic to be recapped? Just let us know. We are not professors again. You could just ask us. Nope. Okay. Okay. So just Adi, just explain P and NMOS a little bit. Basic, like the inputs and the outputs, how they work.
Okay, so here I've explained the concept of channel formation. So just by this channel formation, you cannot ensure water flow, right? You need to have water here. The water illana, there will be no flow. Meaning, if there's no electrons uh, intending to move to the other tank, like to the other, like from drain to source or from source to drain, you will not be having any electron flow, which results in no current flow. What do we want? We want current flow. So that is where the potential which we apply here, the terminals which I drawn there, right? So here we will call it a source, here we will call it as drain. The potential which you apply here matters. Now, if you apply a positive potential at the drain, what happens? The electrons get pulled to the drain, provided you have the channel formed here. If the channel is not formed, how much ever potential you apply at the drain, there will be no electron flow from the source. This concept will be covered later on, where there will be some current due to the electrons directly going from the body to the drain. This is more of like a second order effect, which we'll be dealing later on when we like deal with the depth of the physics part of this MOSFET. But as of now, we'll assume that the case where if the channel is formed and the drain is given a positive voltage in NMOS, there is current flow, meaning there is electron flow from source to drain. Okay, I'll use a different color here. Meaning at the gate is positive, drain is also positive. This implies electron flow from source to drain. Now, what does this imply about the current flow? Where does it flow from? Guys, you can tell. Electron is going from source to drain. Then current flows from where to where? Drain to source. Okay. Since Naveen is saying it is drain to source, we'll just go with that. Okay. So basically, நம்மளோட so-called scientists and researchers centuries back, they decided that, not centuries, maybe decades. Yeah. They decided that the opposite direction of electron flow will be a conventional current flow direction. Okay. So if electrons go in this direction, it implies that current goes in this direction. So let me, yeah, okay. I'll signify this as VD for now. And this will be VG, V drain and V gate. Okay. Now, if VD and VG is positive, this implies current flows from where to where? Drain to source. So the current direction will be in this direction. Now, to bring one more analogy to this, it would be the water tap which you see over here. So now I'll just draw this lousy water tap, lousy excuse of a water tap. And yeah, now if this valve, okay, if this is on, like if you have turned on your valve, or if you have opened your valve, you ensure that there's no block over here for the water to flow, right? So if this valve is open, it is synonymous to gate receiving a positive voltage. Okay. Therefore, you ensure that there is a provision for the water to flow from source to drain. This can be source, this can be drain. Okay. And yeah. So if you don't have any water supply at all, even if you open the valve, there will not be any water to flow through the tap, right? That is where the VDS comes in. V drain to source, the potential difference between drain to source. So if this potential is, if there exists a potential difference, that ensures electron movement. So basically, இங்க தண்ணி இருந்துச்சுன்னா sourceல தண்ணி இருந்தாதான் will be able to receive water through the drain. Okay. Likewise, only when there is a potential difference between the drain and source, you can ensure electron movement from source to drain. How to ensure that electron is negatively charged? What attracts negative charges? A positive potential, right? So we apply a positive potential at the drain, meaning current flows from drain to source. In the concept clear? இவ்வளவுதான் தேவை நமக்கு பேசிக்கா. So tap open பண்ணாலுமே you need a VDS. Even if the gate potential is positive, you need a potential difference between the drain and source for the electron flow to occur. Now, உனக்கு electron flow இருக்கு, வாட்டர்லாம் இருக்கு, தண்ணி வாட்டர் டேங்க்ல தண்ணி இருக்கு, but you have the valve to control the flow of water. So if valve is open, you get the water. If you close it, you don't get any water, right? அதுதான் switch concept. ஆன் பண்ணா circuit வேலை செய்யுது, ஆன் பண்ணலையா circuit is broken, so it does not work. Likewise, even if you have VDS, even if this exists, if VG is not exactly positive, it implies no current flow or no electron flow. Both mean
In this case, it's like a dam, right? தண்ணி நிறைய வருது,
yeah,
but gate is not open, so you can't flow through.
அவ்வளவுதான். So this is the concept of switch. இங்க நம்ம கேட்ல கொடுக்கிறது இட்ஸ் an electronic input. நமக்கு வரப்போறது என்னது? A complete electronic circuit. And the circuit close ஆகும். So an electronic input and an electronic output is the electronic switch. அது வந்து we are using MOSfet for this application. Okay. So you need the gate potential and the drain potential to be positive compared to what? Compared to the source. So any kind of potential difference which you observe is with respect to the source. இது வந்து in the case of NMOS. Okay. So for this to occur, you need to apply a positive potential at the drain. இப்படியே ரிவர்ஸ்ல தான் உங்களுக்கு PMOSல நடக்கும். So PMOSல you will be having what? இங்க P plus, you will be having another P plus, and then substrate. Now, which means you have to pull the holes from where to where. Let me assume this as drain and source. Okay. Source and drain. I don't really see any difference between those. So it is bidirectional. Now, now in the concept, maybe I'll cover it here itself. Maybe here. Yeah. Suppose you apply a positive potential here. What happens? Instead of electrons going from source to drain, the electrons from the drain come to the source. Meaning there's current flow from, okay, I'm erasing, sorry. There's current flow from source to drain, அப்படியே opposite. அவ்வளவுதான். So it's bidirectional. Irrespective of whether it's a source or a drain, it is based on the potential difference which you apply at the two terminals. The source and drain is only for our convenience, which we term, you know. Yeah. Anyway, in the case of P plus, what is more, electrons or holes in P plus? P plus positive, therefore hole concentration is more. So if there's movement of holes, it implies there's movement of electrons too, because holes is nothing but absence of electrons. Now, how to ensure movement of holes? Holes, we assume it, we just assume it for scientific approximation as positive charges. Okay, they aren't exactly positively charged. It just signifies the absence of electrons, which implies absence of negative charges. Therefore, it is positively charged. Now, how to ensure that there is movement of positive charges? You need to bring in a negative potential for it to get attracted. Now, say I'm putting a negative potential over here. What happens? And say that the channel also exists because you applied a gate potential over here, which has to be negative in this case. In the case like we had seen positive. In the case of PMOS, update reverse out. Gate you'll be applying a negative potential for this channel to form. The channel material P it has to be P. It is connecting these two regions, these two P plus regions. So again, this channel will also be P type. Once this channel is established by applying a negative potential at the gate, and when you apply a negative potential at either the source or the drain, here I'm giving it at the source. Okay, negative kuduthingana, there will be holes flowing in this direction, right? Now, what is the current flow direction? It would again be from drain to source. So this is the basic concept. நம்ம எலக்ட்ரான்ஸோட டைரக்ஷன் பார்த்தோம்னா அதுக்கான ஆப்போசிட் டைரக்ஷன் தான் would be current. இதுல கை ரேஸ் பண்ண.
I missed it. You continue now.
Okay. If now we are considering the holes, right? So holes flow are a direction da will be considered as the current direction itself. Here you don't have to invert it. This is the basic concept. இவ்வளவுதான் தேவை உங்களுக்கு. Have I covered P and N? Yeah, PMOS and NMOS is covered. Where in the bro?
Yeah, I think that's it. Just இப்போ வந்து NMOS
I'll just summarize. Do you want to summarize? Okay. அதான் NMOS னு பாத்தீங்கன்னா what do you have? Here you have N plus. Here you have N plus. Here you have the gate. நான் ஃபுல்லா வரையல. Here you have the gate with a positive potential which you apply over here. Put out this oxide layer also. And then because of that positive potential which you apply the gate, you have the channel formed. Because of the channel formation, you ensure that there is a channel or there's a bridge for electron movement. Now, இங்க நான் positive கொடுக்கிறேன், இங்க இருக்கிற electrons attract ஆகும், which pulls this, which pulls this, which pulls this, which pulls this, அவ்வளவுதான். Therefore, there is electron flow from, let me say this as drain and this as source. Electrons go from drain to source, which means current goes from source to drain. Got it? Now, in the case of PMOS என்ன நடக்கும்? You have P plus. Here again you have P plus. The gate potential on the pulling, this is oxide layer and this is metal layer. Here would be the gate potential, which would be negative in this case. And let me assume I'm putting a negative potential here also. All this negative and positive potential is with respect to the source. You keep one particular body as source, like I keep this as source. You always have to refer these kind of potential differences with respect to the source. That is the main concept. That is the main idea. You don't have something called as potential. You only have potential difference. So based on the potential difference, you get to determine whether there's a channel forming, whether there's a channel form, or whether there's electron flow, or whatever it is. Okay. So in the negative pota, meaning the holes go here, holes go here, holes go here, holes go here, which implies holes go from source to drain, and hence current also goes from source to drain. In the case, you don't have to invert. Is this summary okay? This is fine. Any doubts?
Yes, this is good. Any doubts? Yeah. என்ன டவுட்ஸ்னாலும் கேளுங்க, பிரச்சனை இல்லை.
Stephen okay சொல்லிட்டாரு bro. First year cover பண்ணிட்டாரு bro. Stephen bro, basically உங்களுக்கு first sem day you'd be getting this transistor coming in one of your I think third chapter.
Physics.
அப்போ yeah, physics ல வரும். அப்போ வந்து many of us did not know transistors because we did not study it. CBSE curriculum நல்லா இருக்கு. We did not study that. Hopefully this will give you some intuitive idea about this. Transistor க்கு மெயினா யூஸ் பண்ற symbol would be, am I doing it right though? Yeah, somewhat like this, right? You have the arrowhead over here. So if you see this kind of a symbol anywhere in your circuit, you know that it is a transistor. Okay, cool, fine. So far so good. I think I covered everything. CMOS lamp.
No.
Switch it on.
Okay. So, இப்போ ஒரு
CMOS
like what
symbol
happens if we give inputs to P and NMOS? 1 and 0 தந்தா ஒரு digital circuit ல what happens
okay, the
when you give
digital
the input output
implementation
to
of
the
this.
P and NMOS? And guys, Minecraft is coming in 10 minutes. I know we said that ages ago, but வருது கன்ஃபார்மா முடிச்சிட்டு almost. So just stay tuned for that. தூங்கிடாதீங்க.
Okay. So right now, let us consider this symbol. This will be the most digital way of representing a PMOS. PMOS pathina here would be VDD, right? This is VDD or VSS. Okay. This will be drain, VSSR. Okay. This will be source, this will be the drain, this will be the gate. For now, we'll not consider this body. Okay. That can be omitted for now. Now, இப்போ ஒரு வெரி ஆப்ஸ்ட்ராக்ட் லெவல்ல பார்த்தா நம்ம இங்க ஒரு பொட்டன்ஷியல் கொடுக்கணும்னே வச்சுப்போமே. சே திஸ் இஸ் 1 volt which you apply. Now நம்ம என்ன சொன்னோம், இங்க கேட்ல நம்ம என்ன இன்புட் கொடுக்குறோமோ based on that we determine whether there's a channel formed or not, right? So இங்க suppose I give 1, again 1 volt or 0.3 volt or whatever it is, some potential, some positive potential, I give it to the gate. In the case of PMOS, what happens is this symbol over here, the small putty circle symbolizes inversion. So this is something which you'll be studying it as NOT gate. I hope you guys remember. You guys know about this? So you need 1 கொடுத்தீங்கன்னா இங்க உங்களுக்கு 0. What is this 1 and 0? For now, we'll consider this as 1 volt and 0 volt. Okay. So yeah, based on that, நம்ம இந்த மாதிரி PMOSல பார்த்தோம்னா, if we apply 1 volt for the gate, நம்ம PMOSல பார்த்தபோது we have to apply negative. Compared to this, we can see that we compare it to the source terminal, right? So any kind of potential which we apply is compared with the source terminal. அப்படி பார்த்தபோது it's not exactly negative, it is 0. 1 volt, அதாவது VG உங்களுக்கு 1 volt வரும், source உங்களுக்கு VS, sorry, VS is again 1 volt. What is the difference between VG and VS? It is 0, right? ஆனா சாக்ஸ் வந்தாரு, நீங்க தான் சொல்லணும், நீங்க தான் VLS expert.
Yeah.
This is okay, right?
Just I think source chain மட்டும் swap தான் மத்தபடி எல்லாரும்
அப்போ முதல்ல கரெக்ட்டா தான் போடுமா?
ஆமா, நான் நாட்னு பார்த்தேன், நான் NMOS ன்னு நினைச்சிட்டேன். ஓகே ஃபைன்.
அதான் நானே யோசிச்சேன், எனக்கு இங்க ஏதோ இடிக்குதே.
அதான் ஒண்ணும் இல்ல, நான் NMOS ன்னு நினைச்சிட்டேன். ஓகே ஃபைன், எவ்ரிதிங்ஸ்
ஓகே. சோ அப்படி பார்த்தா ஓகே, இப்போ என்ன கன்ஃபியூஸ் பண்ணி விட்டீங்களே.
Hey Adi, it was right before. Source should be on top. For PMOS, source is on the top, drain is on the bottom. Now you'll be giving the current, I mean voltage from the top, right?
Okay.
I was
VSS drain. கரெக்ட்டா தான் சொல்றேன்.
Yes.
நான் சரியா தான் பேசுறேன். Okay. So 1 volt. What happens? இங்க உங்களுக்கு VGS, which is nothing but VG minus VS, which is 0 volt. Therefore, channel is not formed. நீங்க கொடுக்கிற இன்புட் வந்து நீ கேட்டுக்கு கொடுக்கிற இன்புட் 1 வோல்ட்ன்றதுனால உங்க சோர்ஸ் டு ட்ரெயின் போகாது கரண்ட். மீனிங் here you just be getting 0 volt which follow. Meaning this 1 volt does not get transferred over here. Now, suppose if you have put 0 volts over here. Okay, அப்போ பார்த்தா 0 minus 1 would be minus 1 volt. Negative potential இங்க நம்ம அப்ளை பண்ணிருக்கோம். Meaning channel is formed. If channel is formed, இங்க VS ல இருக்கிற potential அப்படியே gets transferred to VD. Meaning this becomes 1. Okay, நம்ம ட்ரூத் டேபிள் போட்டு பார்த்துருவோம். VG சரி, VS னு வச்சுக்கிறேன். VS ல 1 இருக்கு, VGக்கு 1 or 0 போடுறேன். VD என்ன ஆகும்? If it is 1, we get that 1. அதனால 0. Okay? So, this itself is a simple NOT gate implementation, if you see. You give an input, VG is the input, VD is the output. So, if you give a high volt, the 1 volt, we call it as high and low when it comes to digital circuits. It comes to 1 or 0, 2. In the case, we'll stick to any of these conventions. If we apply a high volt or a high voltage to the VG, we see that we get a low voltage at VD. அதுவே இங்க low கொடுத்தீங்கன்னா இங்க உங்களுக்கு high வருது. That's inversion. This is what happens in the case of PMOS. அதுவே NMOSலனா NMOS ஓட diagram மட்டும் வரையறேன் to be the same concept, but will not be having the circle over here. இங்க உங்களுக்கு இந்த circle இருக்கும். இந்த circle இருக்கும். அவ்வளவுதான். Same thing. You just have to do it in the opposite direction. Okay. 1, 1, 1, 1, 0, 0. You can also extend this. இங்க நீங்க 0, 0 போட்டு இங்க 1, 0 இந்த கேஸ கன்சிடர் பண்ணலாம். Meaning, in this case also what happens? If it is 0, அப்படியே reflect ஆகும். இங்க 1 வரும். வராது 0 தான். It again depends on the gate potential alone. So gate potential is like the switch. Once you apply the switch, if the output is not the same as the drain is the output, okay? If it is not the same as the source, in the case of PMOS, அதுதான் உங்களுக்கு inversion ஆகும். அதுதான் நம்ம not getting explain பண்ணுவோம். Even in the case of NMOS, it just follows. This is the simple explanation for this.
Okay. So, if there's not any questions, Minecraft போயிடலாம். You guys let me know.
அது இன்வர்ஷன் எப்படி நடக்குது?
இன்வர்ஷன் அதுதான் இங்க நான் சொன்னல, இட்ஸ் பேஸ்ட் ஆன் தி சேனல். இப்போ நீ VS பொட்டன்ஷியல்ல 1 வோல்ட் கொடுத்துட்ட, VG லயும் 1 வோல்ட் கொடுத்துட்ட. We see the VGS, VG minus VS, and the potential difference. Only if it is negative, we know that in the case of PMOS, there's a formation of channel. If there's no formation of channel, you will not see the same potential which is applied in the source at the drain region.
Okay, if you've been asleep, please wake up. Minecraft is here. So just boot up the game, guys. So everyone just play press பண்ணு, create new world press பண்ணுங்க. Okay, cool. So வந்து நீங்க create new worldல வந்து போய் click creative. Okay, yeah, click creative and then go to advanced and make sure it's a flat world. So உங்களுக்கு கொஞ்சம் ஈஸியா இருக்கும் எல்லாமே பிளேஸ் பண்றதுக்கு. And after that, just hit create. நான் ஆக்சுவலி ஆல்ரெடி ஒரு வேர்ல்டு கிரியேட் பண்ணேன். ஸோ நான் அதுக்கே போறேன். குக்கிங் ஷோல பண்ற மாதிரி நான் வந்து இங்கிலீஷ் ப்ரிப்பேர் மட்டும் காமிச்சிட்டு நான் ஆல்ரெடி வச்சிருப்பேன். ஓகே. So, Ajitesh went out of his way, all, being smart or Lala professor Mari, electronics are the basic fundamental building blocks explain பண்ணா. நான் வந்து மைன்கிராஃப்ட் எக்ஸ்பிளைன் பண்றேன். ஓகேயா, நீங்க வந்து லேப்ஸ் வந்து ஒரு டிசி சோர்ஸ் பார்த்துருப்பீங்க, ஜஸ்ட் ஒரு வோல்டேஜ் தரத்துக்கு. இன் திஸ் கேஸ் we have this block. ஓகேயா, இட்ஸ் கால்ட் a redstone block. இது ஒரு பவர் சப்ளை மாதிரி யோசிச்சுக்கோங்க. ஓகேயா, and this dust over here இது ஒரு wire மாதிரி போறல. This is essentially what it does. It's a wire. So when you connect the wire up to the power supply, there's power running through the wire. So it's a basic or power supply wire in Minecraft. And வந்து நம்ம switch பத்தியும் பேசணும், மெக்கானிக்கல் switch. இங்க வந்து லீவர் இருக்குது, பட்டன் இருக்குது, there are a lot of different types. நீங்க then you could just enable and disable it. So this is a switch. Anyone having any difficulties? If this is your first time playing Minecraft, let me know. I'll keep the control as well. Okay, sorry. என் ஸ்கிரீன்ல இந்த பாட்டம் ரைட்ல ஒரு 3 டாட் ஐகான் இருக்குல்ல. See that? So click that. Okay, yeah. These are all the items in the game. So என்னடா?
அந்த ஆல் எனக்கு எதுவுமே வரல அப்படி பண்ணா.
நீ
அந்த
கிரியேட்டிவ்ல
உங்களுக்கு
இருக்கிறியாடா? Have you
கிரியேட்டிவ்ல தான்
made?
இருக்கு.
Did you make? அட்லீஸ்ட் ஒரு சர்ச் ஐகான் மாதிரி இருக்குதா?
சர்ச் ஐகான் இருக்கு.
டைப் ரெட்ஸ்டோன் லைக் திஸ். ஏதா வருதா?
நோ வரல. வந்துட்டு ஒரு நிமிஷம் எனக்கு வந்துட்டு நினைக்கிறேன்.
வந்துச்சா?
அது என்ன பண்ண
I understand everyone will be on different versions of the game. Hey, sure. Thanks for joining. நீ recording பார்த்து you just do it on your own. And if you're not able to do it right now, you can watch the recording and follow along this as well. பிரச்சனை இல்ல. Actually, I understand everyone will be on different versions of the game, so the UI will look different. நீங்க வந்து you could try to explore that on your own. We are actually running a bit low on time, so I'll keep going a bit forward. Okay. So these are the basic building blocks. Okay, we have a wire, we have a switch, and we have a power supply. ஸோ இவன் வந்து அதிகேஷ் வந்து டிரான்சிஸ்டர் இது அது சொல்லியிருந்தான். அதுக்கும் மைனஸ்க்கும் என்ன சம்மந்தம் நீங்க கேட்பீங்க. டிரான்சிஸ்டர்லாம் ஒரு ஆக்சுவல் எலக்ட்ரானிக் திங். ஹவ் ஆர் வி கோயிங் டு ரியலைஸ் தட் இன் மைன்கிராஃப்ட் யூ லாஸ்ட்? ஸோ ஐ வில் ஷோ தட். ஸோ திஸ் திங் இஸ் கால்ட் பிஸ்டன். ஓகேயா? இட்ஸ் a sticky piston. அதுக்கு நீ ஒரு பிளாக் போட்டனா it will move it front and back. This is what it does. This is its job. So let's say we have a power source here. Okay, yeah. In this case, in Minecraft, this wool block, right? Wool. It's a conducting material. In the power supply, in the wires are off. Okay, yeah. And we have this lamp here that we want to turn on. Okay, yeah. As you can see, there is no current flow. The circuit is open. Just like how Aditya said, like the transistor is open when you don't give it the correct input. Right? Over here, this is what it is. ஆனா உங்களுக்கு current flow வேணும்னா you need this wool block to connect here so that there is power going to the lamp. Okay, yeah. So let's give this piston an input, which is the lever. Okay, yeah. And just in the lever, like 0 and 1 visualize பண்றதுக்கு, I'll put a lamp next to the lever to show that. So what happens essentially here is when there's no gate voltage, there's no current flow. The circuit is open. ஆனா நீங்க இந்த button press பண்ணிட்டு, if you press the lever, you give it a gate voltage. And you can see that there is now current flow. The circuit is closed. So in this case, here your piston is your transistor. So in this case, we got a basic transistor. Okay, yeah. If the input tandana, if you give it 0, the circuit is open. And so you don't get any current flow. Whereas if you give the input 1, it's closed. இப்போ இது actually எந்த boss இப்போ Aditya is covered பண்ணல, how is this acting like? Is it a P or an NMOS? This in this case is an NMOS. Okay, நீங்க 1 தரும்போது the transistor closes and it lets the flow of current through. இதே PMOSனா என்ன பண்ணுனா, when it's 0, we want it to have an input, like have the current flow. So in this case, this is our PMOS. So இது actually எப்படி பண்ணிருக்கோம்னா, we have this other element called a torch. Okay, yeah. So what this torch does, it's a simple NOT gate. When there is an input, when there's not an input, it's on. But if you give it an input, it's off. So what we've essentially constructed here is a simple NOT gate. Okay. So the left is your input side. When you turn on the input, the output turns off. When you turn on the input, when you turn it off, the output turns on. So in the principle, what we're essentially doing is inverting our NMOS to get a PMOS structure. So in input 0 ஆகும்போது, the circuit is connected and allows the flow of current. Whereas when the input is 1, the circuit is open. So essentially what we've done here is implemented what Aditya has been talking about in theory in an actual physical environment that you can walk around and see. So we've so far constructed an N and a PMOS. Any doubt in this? No.
What is the thing which you used here? Am I using the right one here?
So what that is like, Minecraft on the game la enna prachana aguna, your signal has a certain amount of strength. Okay, நீ இப்போ ஒரு பாலை தூக்கி போடுறனா உன் ஆர்ம் இருக்க ஸ்ட்ரென்த் இருக்கும் அந்த டிஸ்டன்ஸ் போகும். Here the DC power supply has a certain amount of strength. In the wool block உள்ள போகும்போது it runs out of strength. So this element here is called a repeater. What it does is just amplifies and repeats the signal back to its original strength. So இப்போ வந்து essentially what it is நீங்க கேம்ஸ் இந்த ரேசிங் கேம்ஸ் விளையாடி இருக்கீங்களா? அதோட பூஸ்ட் பேட் மாதிரி இருக்கும்ல. When you're losing speed, you go over it and it's boosts your speed back up to normal. That's essentially what it does.
Yeah, back to this. Sorry. Hey, Minecraft இங்க trash அது கஷ்டம் bro. I was so engrossed in it. Yeah, we had PMOS and NMOS, right? This is basically the structure, right?
So essentially what we're trying to do is create the NOT gate. Second years நீங்க already DSC ல பண்ணிருப்பீங்க. When you give the input 0, it will come out 1. When you give the input 1, it comes in 0. நீங்க வந்து இந்த gates வந்து just symbol-ஆ you would have been drawn. ஆனா அந்த கேட் உள்ள ஆக்சுவலா என்ன இருக்குன்னா this is what Aditesh is doing right now. So அது ஒரு எக்ஸ்பிளேஷன் அவன் தருவான்.
Okay. So usually நம்ம convention படி பார்த்தா you'll be studying this in your fifth semester also. You will be placing all your PMOS at the top and NMOS at the bottom. Okay. So நீங்க AND gate, NAND gate அதெல்லாம் போக you'll be seeing multiple of these stacked in parallel or இந்த மாதிரி stackலாம் பண்ணலாம் கூட பண்ணுவீங்க. Be connecting this and then you'll be connecting an NMOS இந்த மாதிரிலாம் வரும். So there are these kind of structures. Right now we'll just focus on the one which I've drawn. Okay. Now, yeah. So usually our convention would be to ground VDD and to give PSS a potential of 5 volts. When it comes to digital electronics, 5 volt is termed as 1, is termed as high, and is termed as on. All are the same. When it is 0 volts, it is 0 or low or off. Okay? So, if this is 5 volts, you could say that this is 1. We have a supply of 1 at VSS. This is just a terminal naming convention. Now, இங்க நீங்க கொடுக்கிறது 5 volt கொடுக்கலாம் இல்லனா 0 volt கொடுக்கலாம். Which I'll be writing it as 1 or 0. Right now, we'll consider the condition where we can input 1 and VSS is already 1. இப்போ நம்ம அதுல என்ன படிச்சீங்க அந்த கேட்? If you give VG as 1 and VS as 1, VG minus VS is equal to minus 1. See, the previous calculation. VG minus VS is equal to 0. 0 volts na, PMOS we need to apply negative potential, and 0 தான் கொடுக்கிறோம், meaning satisfied. Condition is not satisfied, therefore channel is not formed. Therefore, இங்க கொடுக்கிற supply, இங்க மேல இங்க கொடுக்கிற supply will not come here. So this 1 over here does not come to this side, therefore it becomes 0. Okay. So far so good. Now, in the case of NMOS, நம்ம கீழே பார்த்தோம். In the case of NMOS, அப்படியே opposite. நீங்க இங்க 1 கொடுத்தீங்க 0 0. இந்த கேஸ் நமக்கு ஒண்ணுமே ஆகாது இந்த கேஸ்ல. So நம்ம அவுட்புட் இங்க தான் எடுக்கிறோம். This is where you see the output. Therefore, when you apply an input of 1 volt, when you apply a high input, you get a low output. So far so good. Now, if we consider the case where you give an input of 0, a low input. When you give a low input, what happens here? A channel is formed. Therefore, this 1 comes over here. We have a channel formed, therefore the 1 travels down here. Again here you see the output 1. இங்க என்ன ஆகும்னு கேட்பீங்க. இந்த சேனல் பேசிக்லி ஃபார்ம் ஆகாதனால this one just gets retained here itself. இங்கே தான் it's the same potential. நம்ம potential it's in the same wire ல. In the same wire there won't be any potential difference. So இங்க என்ன potential இருந்தாலுமே whatever is here will also be here. Same concept. அவ்வளவுதான். ஸோ பேசிக்கா நீங்க பார்க்க வேண்டிய இடம் இது அண்ட் இது. Whatever input you give over here implements this channel at PMOS. Based on this PMOS behavior, you see the output over here. That is all that is required. Idanada, not behavior.
Yes. Okay. Now let me take over here. So if you guys remember the the NOT gate diagram he just drew right now, இங்க மேல இருக்கிறது வந்து இதான் PMOS. Okay, this blue one over here is a PMOS. This is our NMOS. So let me explain this to you again. The way he said it was, the circuit closing, circuit opening. இது வந்து நீங்க மைன்கிராஃப்ட்ல நீங்க விஷுவலா பார்க்கலாம். ஸோ நீங்க இங்க 0 இன்புட் தரும்போது what happens is this PMOS is activated. Okay, the PMOS is activated and it connects the circuit. So what essentially happens is the power from the source is transferred through the transistor and to your output. Since the NMOS is connected to ground, it doesn't really matter. But since your PMOS is activated and allows the voltage and current from the source to flow towards your output, you get the output 1 for the input 0. Let's say your input is 1. What you could see is, even though your power source is still there, your transistor is off. So your circuit is open. So that voltage and current does not flow through. What instead happens is your NMOS is activated because the NMOS activates when the input is 1. And that's connected directly to ground. And what is ground is not just 0. 0 voltage, nothing. It's just grounded. And that's what your output comes to, which is 0. So you see your light is off. What he said theoretically, we could visually see here. So that's why we wanted to do this Minecraft section. Theory, so some people can understand that. But for visual learners, this is a better way to understand it. You can see exactly how the transistor is you could see the open circuit and short circuit. You could see that clearly here. So this is a NOT gate. And one final thing that I wanted to do was show you guys a more complicated gate and its explanation. So before that, I will just explain NAND. So, second years. Second years மட்டும் தான் வைக்கிறீங்க. NAND gate தெரியும்ல? By show of hand. NAND gate. So you have two inputs here. So far, the things we've seen is only one input. Okay, this is your two inputs A and B, and you have your output here. So what's the truth table for this? A, B, out. So before NAND, I think we just go with AND. Okay, So what is an AND gate? When both the inputs are the same, you get the output here. So essentially what that is A, B, out, 0, 0, 0, 1, 1, 0, 1, 1. So when it's 0, 0, you get the output 0. When A and B is there, both of them are not 1, right? Both of them are not 1, so you get a 0 here and 0 here. Only when both the inputs are the same, you get 1. Just like how Aditya said, this circle thing over here is just like an inversion. So what is NAND is just an inverted AND. So எங்கெல்லாம் ANDல வந்து 0 இருக்குதோ அது 1 வரும். இங்க வந்து 0 வரும். That's essentially all it is. So இது வந்து ஒரு NAND gate உள்ள transistor level என்ன இருக்குன்னு கேட்பீங்க. So we'll go for that here. So again, we have PMOS and NMOS. Okay, we have PMOS here and we have NMOS here. So here we know that for PMOS, when the input is 1, it's an open circuit. When the input is 0, it's a short. And it's opposite over here. Input 1 means it's shorted, or shorted as it just allows a flow of current through. Output 0 means it's open. Okay, so I'm going to draw the structure of the NAND gate, and then I'll explain why we got that structure. So up top, we got our power. And then over here, we have two PMOSes in parallel. And then we have two NMOSs in series. And the NMOSs are grounded over here. Okay, yeah. So for each of the P and NMOSs get an input. So the first PMOS gets the input A, the second PMOS gets the input B. I'll put both of them in separate colors. I think that will be better here. So I'll make the input A orange and input B blue. Over here, you can see that one each pair, like a pair of P and NMOS get one input. Okay, yeah. So I'll try to explain how this is a NAND gate, and we'll also. Oh, so sorry, one more thing. We take the output in between this parallel PMOSs and series NMOS, and that's your output. So how does this work, and why does this give the NAND input? So I'll draw the truth table here again. So let's say that your input here is 0 and 0. What essentially does happen? So when your input for the PMOSs is 0, what happens is your PMOS is shorted. So we have a short here. So this voltage over here comes through here and goes towards your output. And this and your NMOS is here. This one is open. So whichever one has and this one is also shorted. I mean, over here. So you have the voltage from the voltage source coming through and going towards your output. Whereas for the input 0, your essentially what happens is your NMOSs are open. So this really doesn't matter. So this is how you get for 0, 0, you get 1. So now let's go for 0 and 1. So essentially what happens is when your A is 0, your first PMOS is shorted, whereas your second PMOS is open because you give it the input 1. For your NMOS, on the other hand, the NMOS which gets A, which is 0 in this case, is open. But the one that is given 1 is shorted. But even in this case, since one of the PMOSs is shorted, you still have the flow of current through your voltage source going towards your output. So even for this case, 0, 1, your output is 1. Let's look at 1, 0. It's basically the opposite of this. The transistor, the PMOS which is shorted, is just switched. So there's still flow of current from your voltage source towards your output. The only case where this output would be 0 is when both of your PMOSs are open circuited. And we know that the PMOS is open circuited when the input is 1. So that's the only case, 1, 1, where both A and B are 1, where you will get the output 0. I'm not sure if this explanation was that great. Aditesh, if you just want to recap it.
I was on another call. Yeah.
Okay. So now that the structure here is clear, we'll show this in Minecraft. This is our NAND gate in Minecraft. This should have been, if you saw our teaser, so you would have always seen this. One thing I want to just highlight here is, you see how in my notes, the lines are like interconnecting? We can't have that in Minecraft. So that's why we have this black wool connection over here. So these, the one in gray is your A. Those are your inputs. So you can see that your A input goes to the first PMOS and your first NMOS. Whereas the black will highlights your B input, which goes to your second NMOS and your second PMOS. So let's go through the working in like an actual physical way. So for the input 0, 0, oh yeah, okay, good. For the input 0, 0, what you could see is both of the P transistors are on and the circuit is short circuited on both sides. So your power from your voltage source, which is your redstone block here, goes towards the output. Aditesh, go turn on the top input. I mean the bottom input, bottom input. Yeah. So in this case, this is your 0, 1, right? So yeah, 0, 1. So since A is 0, your first PMOS is still on, and your first NMOS is still off, right? But since the input B is on, your first PMOS gets turned off. But it doesn't matter because one of the PMOS is still short circuited. Communicate ஒரு PMOS short circuit இருக்குது. Okay, so இருந்தாலும் அந்த voltage source வந்து இங்க வருது கீழே output இருக்கும். It doesn't matter that one of the PMOSes is off. That's why they're in parallel. This is why one of them is in parallel and one of them is in series. So when you use parallel, that means that regardless of one of the transistors being off, you still want the output. So in this case, you can see that even one PMOS being active is enough for the output to be 1. Go put on the input. Ajay, 1, 1, 1, 1. Make it 1, 1. So in this case, we see that since both the inputs are 1, both your PMOSs are open. So you get no output. And then turn off the bottom one. Yeah, turn off. Yeah. In this case, it's the same explanation as before. Okay, or the PMOS is short circuited and it's on. That's enough for the power from the redstone block to go through and meet the output. So this is why we have a parallel and series connection. And this is for NAND. For other explanation, if we put it here for NOR. NOR gate is just, I'll just do OR here. A, B, O. Or what OR essentially means is, if any one of the inputs is 1, you'll get output of 1. 0, 1 is 1. 1, 0 is 1, and 1, 1 is 1. The only input for where the output will be 0 is when neither of them are 1, right? And NOR is the complete opposite of this. So wherever is 0 here, it'll just be 1. So either one the எப்படி CMOS பண்ணனும்னா பார்க்கலாம். So in this case, we would have 2 PMOSs in series, and then 2 NMOSs in parallel. And our voltage source will be here, and our output will be taken from here. This gets the input A, this gets the input B, this gets A, gets B. Okay, yeah. So I will just take this over here. Okay. So until let's say we give this, we make A, we put the input 0, 0. Okay, yeah. Essentially, what happens is when you give a PMOS 0, what happens? It short circuits. Since B is also 0, this short circuits. So the voltage from this goes to the output, resulting in the output 1. So we get the output 1 here. Now, if we give the input 0, 1, what happens here is, since this is 0, we will have, the first PMOS will be short circuited. So voltage will technically be flowing. But since B is 1, this is an open circuit. So this current cannot make it to the output, right? But over here, let's look at the NMOS structure. Since A is 0, this is short circuited. Since B is 1, this is open circuited, and since B is 1, this is short circuited. So what essentially happens is your ground, the ground doesn't actually travel, but this is 0. It's short circuited towards the ground. So your output would be 0. So for 0, 1, you'll get 0. And now when you look at it, for 1, 0, it's essentially the complete opposite of this, right? Your first PMOS will be short circuited, will be open circuited, sorry. Even though this is shorted, it's not connected to the voltage source at all. So there will be no current coming here. And over here, this NMOS will be shorted. So it'll go like this. So your output will still be 0. And for 1, 1, both of your PMOSs are open. So there's no chance for your voltage source to, provide current and voltage towards your output. So this is how a NOR gate works. So let's say you want an AND gate. All you essentially have to do is, towards this output, connect a NOT gate. And now you have an OR. And same thing for here, for the AND gate. Just connected over here. And you have a AND gate. Uh, that's a very rushed and jumbled version of this, but I hope you understand it.
எக்ஸ்பிளனேஷன் புரியுது, பேசுறது தான் புரியுது.
எனக்கு ஒன்றும் தான். வேணா ரெக்கார்டிங் பண்ணும்போது
Yeah, so like Minecraft implementation கூட recordingல பார்த்து கொஞ்சம் follow பண்ணிப்பாங்க. Even I have to revisit it.